The 17th century, on European maps, the oceans were still vast black voids, places where the edge of the world dissolved into wind, fog, and nameless waves. A sailor leaving Lisbon and heading west had no precise idea of where he was. Latitude could be determined from the sun. Its height above the horizon revealed how far north or south he stood relative to the equator. But longitude, east-west position, and more critically, speed. That was a deadly mystery. If you misjudged your speed by just a few nautical miles per hour, after 10 days at sea, you could be hundreds of kilometers off course enough to crash into unseen reefs long before land came into view. For sailors, error was not an abstract number. It was life and death. The survival of an entire crew. The world urgently needed a way to measure motion itself, when everything around was only water and wind. And so, from Roman maps traced by footsteps, to ropes cast into the sea, to early pilots drawing flight paths from nautical charts, humanity gradually evolved from measuring the world with the human body to measuring it through the geometry of the planet. The story of the knot, a seemingly modest unit, is in fact the story of a transformation in human thinking from land to ocean, from ocean to sky. In the era of the Roman Empire, the idea of distance was inseparable from the human body. The statute mile was not originally an abstract figure. It was defined as 1,000 double steps of a Roman legionary from one right footfall to the next. Each step measured about 1.88 meters and 1,000. Such steps formed a millipassus, the origin of the word mile. This was anthropometric thinking measurement rooted in the human form. It was deeply intuitive. The world was scaled to us. But the moment humanity ventured onto the sea, this system collapsed. The ocean leaves no footprints, no landmarks, no fixed points to count. You cannot walk across water. And as maritime empires such as Spain, Portugal, and England expanded, they quickly realized a fundamental truth. An empire of land could not rule the ocean using the measurements of Roman soldiers. Flat units like the statute mile worked well on stone roads, where space was effectively two-dimensional. But the ocean is the curved surface of a planet, a spherical structure where every meter traveled bends around Earth's center. Applying land-based miles to the sea was like using a city map to navigate the moon. The error lay in the very foundation. This was the birth of geodesic thinking, the realization that Earth is not merely a place we inhabit, but a reference system that must be calculated. From this insight emerged the nautical mile. Instead of footsteps, it was based on Earth's angles. 1 minute of latitude became 1 unit of distance. This shift was more than scientific, it was a revolution in perception. Humanity moved from "I measure the world by myself" to "I measure the world by its own shape." During the Age of Exploration, as ships first crossed the Atlantic, humanity stood between two eras. Scientific understanding was awakening, but daily practice still relied heavily on folk intuition. Without engines, radar, or electronics, sailors depended on wind, stars, and a deceptively simple device that would transform navigation: the chip log. Imagine it, a triangular wooden board tied to a long rope. Along the rope, knots were tied at fixed intervals. A sailor tossed the board into the sea, where water resistance slowed it down, while the ship continued forward, pulling the rope out behind. When a 2.8-second hourglass ran out, sailors counted how many knots slipped through their hands. Each knot corresponded to 1 nautical mile per hour. Thus, the unit knot was born, a fusion of hands-on experimentation and mathematical precision. Why 28 seconds? Why were the knots spaced 47 feet 3 inches apart? It was no accident. These values were scaled directly from Earth's circumference. In 28 seconds, a ship traveling 47 feet corresponds to a speed of 1 nautical mile per hour, equivalent to moving 1/21,600 of Earth's circumference per hour. Humanity had effectively compressed the entire planet into a single rope. The chip log marked the turning point between intuition and mechanics. For the first time, ships could truly know how fast they were moving. Within every knot lay both early scientific reasoning and raw survival instinct. Sailors counted knots as if counting the ship's heartbeat and through it. They felt the pulse of the planet itself. 3 centuries later, in 1927, when Charles Lindbergh took off from New York aboard the Spirit of St. Louis, bound for Paris, he did not fly with GPS. He had no radar guidance. What he carried instead was astonishingly familiar maritime charts, a compass, and celestial navigation tools originally designed for ships. In those early transatlantic flights, the sky became another ocean, a sea of air. Pilots, like sailors before them, determined position by latitude and longitude, and measured speed in knots. Why? Because aviation was born from maritime thinking. Engineers, designers, and regulators all inherited a worldview shaped by spherical geometry. Switching to kilometers per hour would have thrown charts, wind tables, and meteorological formulas into chaos. The knot preserved coherence, motion, position, and time all spoke the same planetary language. This logic extended further. During World War II, bombers used nautical charts to calculate wind drift, drop angles, and airspeed. In modern civil aviation, radar, GPS, and satellite data all reference latitude, longitude, and speed in nautical miles per hour. From ocean to stratosphere, humanity did not invent a new language. It borrowed the language of the sea. The ocean had taught humans how to see the world from above. There are no absolute straight lines, only the curves of a planet. By the mid-20th century, as globalization accelerated, a new problem emerged. Britain and the United States disagreed on the length of a nautical mile. In Britain, it was based on the 1,836 standardized Earth ellipsoid 1, Babawushasen, 184 meters. In the United States, it measured 1, Babawushasen, 218.40 meters. That tiny difference, mere centimeters, became a nightmare for international standardization, especially in aviation. Only in 1954 did the International Hydrographic Organization (IHO) settle the matter. 1 nautical mile equals 1,805.25 meters. This agreement marked the end of the era of fragmented units and the beginning of a shared planetary language. Today, every ship, every aircraft, every satellite speaks the same tongue, the language of knots and nautical miles, not out of habit, but because it is the only language compatible with Earth's geometry. From the footsteps of Roman soldiers on land, to sailors' ropes drifting in waves, to pilots navigating by stars, humanity has shifted from measuring the world with the body to measuring it with the universe. The knot is not merely a unit of speed. It is a symbol of humanity's cognitive evolution, a recognition that to master the planet, we must first be humble before its shape. Every knot is a reminder. Humanity advances not by forcing its measures onto nature, but by learning to measure itself in the language of the stars.